Hello everyone, welcome to 10 minutes says XOR queries of a subarray. The question states that we are given an array of queries, an array of some integers. For each query, we have to give the output in an array such that, let's say we are given a query 0 to 1. We have to find the XOR of elements starting from index 0 till 1. So that will be 1 and 3. So we'll XOR 1, XOR 3, then we'll get 2. That will be the ith element of our output array. So what will be the brute force for it? For each query, we can loop over from left till right, and for each element in that range, we can find XOR of them and store it on our output array. As said, we will be initializing our output array as answer with the size as queries.length, and we can start our index with 0 for our answer, and we can, for each query in queries, we will have a start and the end of that query, and we can find XOR of all those elements within that range, and after that we will store our output in our answer array and then return it simply. Let's see if it runs. Let's see if it gets submitted. So what will be the time and space complexity for this solution? The time complexity will be, let's say we have m number of elements here and we have n number of elements here. So our time complexity will be big O of m cross n, whereas we haven't used any extra space, so it will be constant. The space that we are using for output is actually not counted. Can we do better? Yes, we can. Let's revise the key properties of XOR. The XOR of a number with itself is 0, and the XOR of a number with 0 is the number itself. So if we know the XOR of 1, XOR 3, that is the XOR of elements from range 0 till 2, then can we find the XOR of numbers from 1 till 2, that is 3 XOR 4. So if we need to find what is the XOR of this, can we XOR the complete computation with 1, which is the remaining elements of this range? So in this case, 1 XOR 1 will become 0, and 0 XOR the remaining elements will be our remaining elements XOR itself. So using this property, we can find the XOR of the required range. So what we can do is, we can pre-compute our XOR of all the ranges from 0th till the nth index, and can find for each range by using a simple formula as XOR of left minus 1 with XOR of till the range our right. So our right will be containing the XOR of all the elements till that range, whereas and the XOR of L minus 1 will be having XOR of all the elements before that. So we will be initializing our prefix array, and we will be using 1 based indexing for our prefix array. So our prefix I plus 1 will be storing the XOR of all the elements from 0th index to I index. Why we are using 1 based indexing for prefix? Because let's say our query is having the left as 0. So according to our formula, we need to find the XOR for all the elements. So according to our formula, the XOR of our range will be left minus 1 XOR right. But left minus 1 will be minus 1 in this case, which will go out of bound. And hence we should use 1 based indexing for prefix array. So we will be populating our 0th element for prefix as 0, and the other as prefix I plus 1 will be prefix of I with the array of I. And then we can find the start and end of our query and find the XOR of that range, that will be from start till end plus 1 in our prefix, as our prefix is 1 based indexed. And we can store our output in our ans array and can return the ans. The time complexity for this will be, here we are using big O of n, and here we are using big O of m. So our time complexity will be big O of, so our time complexity will be big O of max of n comma m, which is equivalent to big O of n itself, and our space complexity will be big O of n, as we are using extra space for our prefix array pre-computation. Thank you for watching.